Assalamualaikum and very good day to Dr. Fazlina. My name is Misha Farini binti Muhammad Rani from BA 111 4B. Today I will presenting my individual assignment is pipeline transportation and my case study is Sabah Sarawak Gas Pipeline 2014. Next, I will explain about introduction for pipeline transportation. What is pipeline transportation? It is a movement of fluid materials such as oil, natural gas, water, and liquid chemical through a fixed and enclosed system of pipe. It operates using a continuous flow system that allows large volumes of uniform commodities to transport efficiently over long distance. As a fixed infrastructure mode, pipeline ensure control, consistent, and reliable movement of energy product across regions. In this report, I will explain the main character, the advantage and disadvantage, the infrastructure and network involved, the policy, the stakeholder, as well as the issue and challenge of pipeline transportation. This point help us understand how pipeline systems operate and why they are important from national energy distribution and security. This topic is connected to the Sarawak pipeline incident in 2014, where a section of the gas pipeline caught fire near Lawas. The incident showed the operational risk, safety concern, and the importance of having a strong emergency response. It also highlights how pipeline disruption can affect communities, industry, and the overall effectiveness of the energy system. Next, I will explain about characteristics of pipeline transportation. First characteristic is continuous operation. Pipeline operate 24 hours a day with minimum human input, ensuring a steady and uninterrupted energy supply. Next, high volume capacity. Pipelines can transport a million of liters daily, as a single gas pipeline can replace thousands of tanker trucks. Next, high initial cost but low operating cost. It is because building and installing pipeline is capital intensive, but once the flow is established, operational costs become very low. Next character is commodity specific. Pipelines are designed for specific products such as oil, gas, water, and cannot be easily switched to carry other material. For last criteria is mostly underground and subsea. Pipelines are usually installed the underground or underwater, reducing visual and environmental impact, but making maintenance and repair more difficult. Now, I will explain about advantage and disadvantage of pipeline transportation. For advantage, we have 4 advantages. And the first differs continuous and reliable flow, which is pipeline can send material non-stop, no matter the weather or traffic. For example, a water pipeline can supply clean water to a whole town every day without interruption. Next, low operating cost, which is after building the pipeline, it needs a little maintenance or worker. No time is waste on loading, unloading, or move goods between vehicles. For example, oil pipeline can transport fuel long distance cheaper than using truck. Next, high energy efficiency. Pipeline use very little fuel and create less pollution per ton of material moved. For example, natural gas pipeline use far less energy than transporting gas by road. Next, environmentally friendly. Pipeline underground cause less noise, traffic, and air pollution. For example, underground water pipelines reduce the need for many water trucks on the road. Now I will tell about disadvantage. For advantage, first thing first, we have high capital investment, which is building pipeline by buying land and installing safety system are very expensive. For example, some gas pipeline in Malaysia cost billions of ringgit to build. Next, inflexibility. Pipelines usually carry only one type of material at a time, and changing the route is very costly. For example, you cannot easily move an oil pipeline to a new town. Next, leaking and environmental risks. This because pipeline can develop leak or break, cause spill or accidents. For example, a gas leak can pollute nearby land and water. Lastly, security and safety concern is because pipeline can be damaged by the sabotage or natural disaster like flood and landslide. For example, heavy rain can cause a landslide that damage underground pipelines. Now I will explain about infrastructure and network and policy. Now I will explain the infrastructure and network. We have 5. First thing first, Peninsula Gas Utilization System. Malaysia Main Gas Pipeline Network, 2,500 km, connecting Terengganu, Pahang, Selangor, Negeri Sembilan, Johor and Penang, with a capacity of 2,000 mmscfd. Next, Sabah Sarawak Gas Pipeline, a 512 km onshore pipeline linking Kimanis, Sabah to Bintulu, Sarawak to supply gas for LNG process and domestic distribution. Next, Trans Sabah Gas Pipeline, a planned 500 km pipeline from Kimanis to Sandakan and Tawau, currently on hold due to terrain and cost constraints. Next, Industrial and Utility Pipeline include the 67 km Langat to water supply pipeline and the Kerteh to Kiban petrochemical pipeline transporting ethylene, propylene and naphtha for industrial use. Lastly, K network function and connection. Pipeline supply gas to TNB power plant, major industrial hubs, which is Pasir Gudang, Gebeng, Shah Alam, and linked to the Singapore gas transmission system. Next, I will explain about policy. We have 5. First, Petroleum Development Act 1974 grants Petronas exclusive ownership and right to develop, operate, and transport petroleum resources, including pipeline, while ensuring safety and environment compliance. Next, Gas Supply Act 1993 allow open access to pipeline infrastructure, promoting competition and transparency in gas supply. Next, Environmental Quality Act 1974 EQA require environment impact assessment for all major pipeline projects and ensure environmental protection. Next, Pipeline Safety and Integrity Regulation set standard for leak detection, corrosion control, SCADA monitoring, inspection, and emergency response to ensure pipeline safety. Lastly, land acquisition and right-of-way policy regulate land use, compensation, and safety restriction along pipeline corridors. Now I will explain about issue and challenge. We have 6 issue and challenge. First, understand the pipeline landscape. Pipeline face technical challenge like leak, corrosion, or mechanical fault, so operator must understand the network thoroughly to maintain safety and reliability. Next, navigating legal and environmental requirement. Because compliance with environmental law and safety regulation is essential to avoid delay or penalty. Next, building and expanding pipeline network. Constructing pipeline across mountains, wet or unstable soil require careful planning and engineering. Next, mitigating risk and ensuring operational integrity. Pipeline face threats like sabotage, explosions, fire, and leak, requiring robust monitoring and maintenance. For addressing community and social concerns, local community may raise safety or environmental concerns which must be managed to prevent project delay. Lastly, managing economic and environmental challenge. Pipelines are expensive to build and maintain, and extreme weather can disrupt supply, requiring strong financial and risk management. Next, stakeholder of pipeline transportation. For government agency, we have Ministry of Energy, Energy Commission Suruhanjaya Tenaga, Department of Environment. For transport operator, we have Petronas, Sarawak Shell Berhad, Construction Engineering Contractor, Pipeline Maintenance Service Provider. For consumer, we have industrial gas user, for example, power line factories. We have domestic gas customer, LNG processing plants, oil refineries. For environmental group, we have Malaysia Natural Society to monitor environmental impact. WWF Malaysia advocates sustainable resource management. Local NGO focus on river and forest ecosystem protection. For community organization, we have landowner association along the pipeline road, village or district communities affected by pipeline construction. We have indigenous community council in Sarawak. Now, I have to explain the basic of pipeline transportation. I will move on to the case study. For this presentation, I choose the Sarawak pipeline incident in 2014. This case will help us to see how the concept we discussed apply in real situation, especially in terms of risk, safety, and system effectiveness. The Sabah Sarawak Gas Pipeline is a major gas transportation infrastructure project operated by Petronas, designed to transport natural gas from the Kimanis Oil and Gas Terminal Sabah to processing facility in Bintulu, Sarawak. In 10 June 2014, the SSGP experienced a major pipeline explosion and fire near Lawas, Sarawak. This case study examines the interaction between pipeline component and stakeholder, the impact on efficiency and effectiveness, as well as the issue and challenge arising from the incident. For component and stakeholder interaction, I will explain the key component of the pipeline system and the main stakeholder involved in its operation. For component, pipeline infrastructure, over 500 to 660 km of gas pipeline involve monitoring system. Control system is a gas pressure and flow monitoring system to manage safety. A safety mechanism, blowdown system, emergency shutdown valves, and fire response protocol. For stakeholder, we have Petronas, which is pipeline owner and operator responsible for design, maintenance, and safety compliance. For government agency, Department of Occupational Safety and Health and environmental authorities responsible for regulation and monitoring. Local communities, residents near the pipeline route whose safety and land right were impacted. Lastly, contractor and emergency response teams responsible for construction, maintenance, and incident response. Now I will explain about how incident affect the efficiency and effectiveness impact of the pipeline system. This point shows the real operational impact that happened after the pipeline failed. For the first point is supply disruption. The incident caused the gas flow to be stopped immediately, reduce efficiency because the system could not operate continuously. Number 2 is increased downtime. Repair process and safety procedure extend downtime, lowering effectiveness by limiting the pipeline's ability to reliably supply gas. Next, higher maintenance costs. The needs for expensive repair makes the pipeline less cost-effective, reduce its overall economic efficiency. Next, reduce reliability. Recurring incident decrease stakeholder confidence, indicating that the pipeline cannot provide a stable supply consistency. Lastly, alternative transport needs. We have Petronas had to rely on slower and more expensive backup routes, reducing the overall efficiency of the energy supply system. Next, I will discuss about main issue and challenge related to the pipeline system. This point highlight the operational, environmental, and safety problem that makes pipeline management more complex. First issue is risk, leaking, and corrosion. Pipelines tend to experience corrosion from time to time, which can lead to gas leak. Regular maintenance is required to prevent environmental hazard and safety incidents. Next, high capital and operating costs. Construction and land acquisition and maintenance are expensive. This can affect the overall efficiency of the pipeline project and increase the financial burden. Next, remote and difficult areas. Thick forests, rivers, and uneven terrain in Sarawak make pipeline construction and monitoring challenging, slowing down operation and increase risk. Next, security threats and vandalism. Pipeline in remote areas are vulnerable to theft, illegal connection, or sabotage, which affect the reliability and efficiency of gas transportation. Next, compliance with regulation and the environment. Strict environmental and safety regulation require continuous monitoring and approval, which can delay project and impact operational efficiency. Now I will present several recommendations to improve pipeline safety and efficiency based on the issue identified in the case study. For the first recommendation, enhance pipeline monitoring and maintenance. Use real-time system and regular check to detect leaks and faults quickly. Next, strengthen stakeholder coordination to improve communication and collaboration between government agency, contractor, and local community to ensure time project execution and reduce delay. Next, develop comprehensive risk management protocol. For establish clear emergency plans and train personnel for quick response. Next, invest in training and local capacity building to provide specialized training for local workers and technical staff in pipeline operation to ensure sustainability and reduce dependency on external experts. Lastly, sustainability and environmental protection to minimize ecosystem disruption and use durable material. For conclusion, the Sarawak pipeline case of 2014 highlight both the strengths and vulnerabilities of pipeline transportation. While pipeline provide an efficient and controlled method for transporting large volume of fluid like natural gas over long distance, the incident revealed the risks associated with maintenance, operation fail, and environmental impact. Effective coordination among stakeholders, stringent safety protocol, and robust infrastructure planning are essential to ensure reliability and minimize disruption. This case underscores the critical role of pipeline system in energy supply and demonstrate how proactive management can enhance both efficiency and effectiveness in pipeline transportation. Pipeline transportation can become more resilient and capable of preventing similar disruption in the future by enhancing pipeline monitoring and maintenance technology, strengthening coordination among stakeholders, and implementing stricter safety and environmental protocol. That's all from me.